So would to the fourth one, the number would be like x to the first plus 5x to the fourth plus 12x to the... No.
You lost it. But just answer these questions. We'll get to it. We'll get to it. Just answer those questions. It goes 2, 1, 1.
But like when you started, it was like if you have that, but it's not like simplified.
If it's not
Like
simplified?
if you haven't combined the terms yet.
Oh, okay. So I didn't combine the terms yet. Oh, I see what you mean. Before you get to this stage.
Yeah, I mean like because I did it like the long way. So like before I had like put x to the fourth and 2x to the fourth like together, then like that's how they went.
Oh, okay. I see. So the stage right before this had that pattern. Okay. What about this pattern, though? Because that definitely should have a pattern, because this one has a pattern. So the one before it should have a pattern, too. What pattern do we see about the coefficients on this one? There's no pattern? Even a simple one? Just like they increase or they decrease, or they're all the same number, or yeah.
They increase.
And then they decrease, right? Because they go 1, 4, 6, and then they go 4, 1. This goes 1, 3, 3, 1. This goes 1, 2, 1. Well, these don't increase because they're too small to actually see the pattern. So we should assume that in the next step it should go 1, bigger, 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 smaller, 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 until you get back to 1, right? So they increase, then they decrease symmetrically. So whatever's on this side, so there's 4 is on one side of the 6, 4 is going to be on the other side. So they're going to increase, then decrease symmetrically. Increase, then decrease symmetrically. All right, so without filling in that pyramid, we actually know a whole lot about binomial expansions just from doing what we did so far. Because without the coefficients, so pretend like I don't know this 4, this 6, and this 4 here. We still know a bunch about it from it because, like Yashin said, my very first x value should be x to the 4th. And then Macy said, well, it decreases along the way. So we know it started at x to the 4th, then go x to the 3rd, x squared, x, and finally we'd have no x's. And then the y's, they'd count up. So where we have x to the 3rd, I'd have y to the 1st, and I can double check it because 3 plus 1 better equal 4. So you should be able to do all of this minus the coefficients right now. So that was something you could have already done. Now we're going to add Pascal's triangle into it so we can get our coefficients. Well, Pascal's triangle, at the very top of this guy, we're going to have a 1. That leads us off. And then the 2 below it are also going to be 1 and 1. Then we're going to go 1 again. And then we're going to do 1 again and 1. No, I'm just kidding. We're done with the 1s for a little bit, just for right now. Then we're going to notice that if I combine 1 and 1 from up here, this is going to equal 2. Then we have to go back to 1. Then we're going to start with 1. And this time we're going to combine that 1 and that 2 that are right above the next box. And this is going to be 3. We're going to combine that 2 and this 1 to make 3. And my last box is going to be 1. Then we continue down and we're going to have 1, 4, 6, 4, 1. And finally, we're going to have 1, 5, 10, 10, 5, 1. And we could continue on if we needed to. How do these numbers compare to our coefficients? They're the exact same. So if we put Pascal's triangle along with what we learned from those questions, we actually know how to do any binomial expansion no matter how big or how small. So I just want to put here that these are the coefficients in a binomial expansion. So these are the coefficients in a binomial expansion. Which is pretty cool, and we should probably know that earlier, because how much time did we spend on just doing x plus y to the fourth? How many classes have we had stuff like that, and we had to do it over and over and over, where it's just a pattern. It's just a pattern, and we're going to put it into practice on these next two problems. Yeah?
Wait, can you go back one quick second?
No. Wait, which one? This one?
Yeah.
Okay.
No, other one.
This one?
Yeah.
There. One quick second or just one full second?
I'm good.
Oh, okay. That really was a second. All right, so we're going to expand x plus 2 to the fourth, and we're going to use the patterns that we already know. So I'm going to exclude the coefficients for right now. I'm just going to put a little blank for my coefficients. I'm going to pretend like we don't know that Pascal stuff. I'm going to focus on my x's and my 2's to start off with. So we need to start with x to the fourth, because that's what we start with. We start with our very first term here, and we do it to the fourth. Then our next thing, so I'm going to leave a blank for my coefficient. We're going to drop that power down to 3, because our very first term is going to go 4, 3, 2, 1, and then it's going to drop out. But as soon as this one goes to 3, we know it has to add up to 4. So it must be we're multiplying by our second one to the first. And now as that x goes down, the powers go down, our 2's powers are going to go up. So now we're going to add x squared times 2 squared. Our powers still add to 4. Then we're going to add x times 2 cubed. And finally, we're going to add, well, our x's are going to drop out, and we're just going to have 2 to the fourth. Who's going to be the brave soul that tells me what my coefficients are in this guy? What are my coefficients on this one? Who wants to take a guess? Mason? 1, 4, 6, 4, 1. That is correct. 1, 4, 6, 4, 1. And that was this column here. So that must mean anytime I have x plus y to the fourth, I'm going to use this row. And we can apply that to the row before. The row before is going to be anytime I see x plus y to the third. The row above it will be x plus y squared. The row above that is just going to be x plus y. And finally, the row above it would be x plus y. Oof, that wasn't a y. That's a y to the 0th power. And we can continue on. X plus y to the 5th, 6th, 7th, 8th, 9th, 10th. So we could write this out every single time. All right. I'm going to go ahead and simplify this. So this is actually going to simplify down to x to the 4th plus 8x cubed plus 24x squared plus 32x plus 16. All right, it didn't take any distributing. It was just memorizing that pattern or knowing that pattern. Okay, our next one is x minus 3 to the 5th. That minus is going to switch stuff up, but not in a huge way. We're still going to keep our pattern the same. We're still going to say, well, my very first coefficient is going to be x times x to the 5th. Then we're going to add, pretend like I don't know my coefficient yet. That's going to be x to the 4th but I have to bring in my other term, which is going to be negative 3. We're going to bring in a negative 3. So you could, if you wanted to, you could rewrite this as x plus a negative 3 to the 5th, or just remember you bring down a negative 3 here. And that's to the first power. Then we're going to keep that pattern where x is drop in power, so we have x to the 3rd, negative 3 squared, plus our coefficient times x squared times negative 3 to the 3rd, plus our missing coefficient, x times negative 3 to the 4th, and finally our x's drop out, and we're just left with negative 3 to the 5th. Help you guys out here. I bet you the first one's 1 and the last one's 1. Can someone fill in my missing coefficients? Abby? Yep. 5, 10, 10, 5. All right, then fully simplified. I'm just going to write it down. We're going to have x to the 5th. We're going to have minus 15x to the 4th. We're going to have plus 90x cubed minus 270x squared plus 450x minus 243. Fully simplified. Not always the simplest math, especially when it expands as much, but it's way easier than having to distribute and worry about a binomial times binomial times binomial times binomial and keep distributing. This makes your life a lot easier. All right, now we're going to throw another wrinkle into that Precalc triangle thing. And this wrinkle is going to help us so we don't have to write, like let's say I want to do x plus 3 to the 12th. I don't want to have to write 13 rows on my Precalc triangle every single time I want to do something really big. So the reason why we learned combinations before this section is because we can turn Precalc's triangle into a series of combinations. So remember that from yesterday I said combinations can either be written this way, or they can be written C and R, or they can be written like this, where we have n over r. And that's what we're going to do. So what I have here is actually Precalc's triangle. 0 choose 0 is 1. 1 choose 0 is 1. 1 choose 1 is 1. 2 choose 0 is 1. This is 2. This is 1. This is 1. 3, 3, 1. And it works out throughout all of Precalc's triangle. And what makes this nice for us is because if I wanted to get to, I don't know, 10 choose 0. So if I want to get way down here, I can just start there. I can just start there rather than having to build up my triangle all the way there. Which leads us to the binomial theorem. And that is using this fact to say I can come up with my leading coefficient as long as I know my n value and my r value, which we're going to talk about in this next one. So this is the binomial theorem expansion, but I think it makes more sense when we actually do it in practice. So I'm going to skip right to the first problem. So the first problem says write the first 3 terms in the expansion, x minus 2y to the 10th. So yes, we could do Precalc's triangle until we get to that 11th level to do our 10th power. But I don't want to do that. We're going to use that binomial theorem that we had before to help solve this. So our first 3 terms. So how this is going to work is we're going to use a combination for each of our coefficients. So we're going to start with a combination. And the top of our combination is always going to be our original power. So the top of our combination is going to be the original power, which is 10. Let me make this a little bigger. So it's always going to be, that's where we're going to start at. our very first combination, our very first coefficient is going to be 10 choose 0. In other words, you're saying, this is my first term, 10 choose 0. And then we're just going to do the powers like normal. We're going to start with x to the 10th. Because we always start with our very first lead term to the 10th power. Well, that's our first term. Our second term is going to be, so we're going to add 10 choose 1. So we're going to increase that bottom number. So it's going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 until I get to 10. And now we got to write our variables. So it's going to be x to the 9th times that negative 2y to the 1st. I want to note something really quick. This number that's on the bottom of our coefficient is always going to match the number on our second item. The top number may not always match this, but this bottom number will always match that number there. So our next one, we're going to add 10 choose 2. And that's going to be x to the 8th, negative 2y to the, well, we either know 8 plus 2 is 10, or we're increasing, or we're going to realize that we do 10 choose 2, so this needs to be a 2. So once again, those need to match up. And then we're just going to continue, but they only say do the first 3 terms. So that's all I'm going to do. All right, I don't have a ton of room below, so I'm going to do my work off to the side. What's 10 choose 0? How many ways are there to choose nothing? There's just one way. And we'll confirm that again if you're a little stuck on that. But 10 choose 0. We already know it should be 1. Our first term should always be 1. Let's just double check. So 10 choose 0 is 10 factorial divided by 10 minus 0, which is 10 factorial, times 0 factorial, which is just 10 factorial over 10 factorial, which equals 1. So simplifying that, that's 1 times x to the 10th, so it's just x to the 10th. All right, our next one is 10 choose 1, which, like I said, too, you can use your calculator for this. I'd be more than happy to let you use your calculator on this, which just enter 10, go to that math probability section, hit that C, and then hit 1, and it'll pop out an answer. But this is going to be 10 factorial over 9 factorial, because 10 minus 1 is 9 factorial, times 1 factorial. Can someone tell me what that equals? What is 10 factorial? Without using your calculator, what's 10 factorial divided by 9 factorial? It's just 10. Yeah. So that's 10. So in fact, we have 10 times negative 2, so this is going to be a negative 20. X to the 9th. Don't forget about the y to the 1st. Next, we're going to have 10 choose 2. 10 choose 2 is 10 factorial. Divided by 10 minus 2 is 8 factorial. Times 2 factorial. Can someone tell me what that one equals?
45. 400.
Not 450. It is going to be 45. Can you tell us how you did that?
I simplified because the 8 can cancel out, but if you just imagine it's 10 times 9 times 8, and then you're only left with 9 times 10, which is 90, and then 2 factorial is just 2 times 1, which is 2, so 90 divided by 2 is 45.
It's 45. Yeah, perfect. I couldn't have explained it better myself. So we have 45, but we're going to have 45 times negative 2 squared is 4, so it's 45 times 4, which is going to be 180, so it's plus 180, x to the 8th, y squared. So it really comes, you have to simplify correctly. There's a bunch of stuff to simplify. All right, they said find the first 3 terms, so we are done. We just go dot, 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 and we are done. Okay, our next one says, what is the coefficient of a to the 7th b squared in the expansion a plus b to the 9th? So once again, I don't want to write out the Pascal's triangle all the way and figure out where a to the 7th, b to the 2 is. So we're just going to start off with the fact that I know that leading coefficient of a to the 7th, b squared, is going to be some combination. It's going to be some combination. I just have to figure out what goes on top of that combination and what goes on the bottom of that combination. Does anyone know what, or raise your hand and tell me what you think the top number is going to be? What is the top number here? 2 people have a guess? 3 people? 4 people? Juliana?
9.
It is going to be 9. It's going to be our total number that we started with here. Or you can say 7 plus 2 is 9 as well, because 7 plus 2 better equal my original expansion. So in fact, I didn't even need to give you any of this. I could have just said, what is the first term in the coefficient a7 b squared if it's a binomial expansion? I could just say that. You would have to realize that 7 plus 2 gives me my starting exponent, which is 9. But either way, it is our starting exponent, which is our 9, that is going to go on top. Right there. All right, what goes on the bottom? What goes on the bottom? Carolyn? 2 goes on the bottom. Because you remember from the one before it, I said this bottom number always matches with our second exponent. All right, so if my second exponent is b, so we have a to the 7th, b squared, we're going to take that 2 and we're going to throw it on the bottom. So I'm just going to take that 2, I'm going to put that on the bottom. All right, so our leading coefficient is just 9 choose 2. Well, 9 choose 2 is 9 factorial over 9 minus 2, which is 7 factorial, times 2 factorial. Who can give me that total? Carolyn, you got my last one. Macy, did you get one of these? Okay.
36.
It is going to be 36. Can you tell us how it's 36?
Yeah, so when you have the 9 factorial over 7 factorial, the only ones left would be 9 and 8 on the top.
Mm-hmm.
And then 9 times 8 is 72, divided by 2 is 36.
Perfect. Yep. So our leading coefficient is just 36. Not an obnoxiously hard problem, but if you don't understand what's happening, it becomes a really hard problem. Right? Especially with a test, and we got to remember this. So this is important. This is important. This should be a quick problem, but if you don't understand this, it's going to be a long problem. So based on that, are there any questions? Okay, do we have any questions from the homework?